Good morning, students. Let us continue from where we have stopped yesterday. The next question is integral sin hx plus 1 by x square minus 1 power 1 by 2 dx. This is integral sin hx dx plus this is x square minus 1 whole power 1 by 2 is root. So this is 1 by root of x square minus 1 dx. So this is equals to integral sin hx dx is cos hx plus integral 1 by square root of x square minus 1 dx is cos h inverse x plus c, or cos hx plus this has got another formula which is log x plus square root of x square minus 1 plus constant of integration c. The next one is integral a power x minus b power x whole square by a power x into b power x dx. So this is equals to, this is a minus b whole square, a square plus b square minus 2ab. So a power x whole square, a power m whole power n, a power mn. So this is a power x whole square is a power 2x. This is plus b power 2x, a square plus b square minus 2ab. 2 into a power x into b power x by a power x into b power x whole dx. This is equals to a plus b minus c by d, a by d plus b by d minus c by d. So integral is to be integral dx is to be shared for three functions. So this is a power 2x by a power x into b power x dx plus b power 2x by a power x into b power x dx minus 2 a power x into b power x by a power x into b power x gets cancelled. We are left with the 1 dx. This is equals to a power 2x by a power x. So bases are equal, exponents are to be subtracted. A power 2x minus a power x is a power x by b power x dx plus b power 2x by b power x is b power x by a power x, b power x by a power x dx minus 2 integral 1 dx. So this is equals to a by b whole power x. A power x by b power x is a by b whole power x plus dx plus this is b by a whole power x dx minus 2 integral 1 dx. So let us suppose this to be a. Integral a power x dx is a power x by log a. So this is a by b whole power x by log a by b. Let us suppose this to be x. So integral a power x dx is a power x by log a. So is the case with this also. This is b by a whole power x by log b by a minus integral 1 dx is x plus constant of integration c. So this is equals to log a by b is log a minus log b. So 1 by log a minus log b, if you take common in both of them, this is a by b whole power x, this is minus b by a whole power x, because log b by a is log b minus log a, but we are taking log a minus log b, therefore it is deferred by a negative sign, minus 2x plus constant of integration c. Integral secant square x into cosecant square x dx. How do we do this? So secant square x can be written as 1 by cos square x into this is 1 by sin square x whole dx. So this is equals to, this is 1 by sin square x into cos square x dx. So 1 can be written as sin square x plus cos square x is 1. So this is sin square x plus cos square x. So in the place of 1 we have written sin square x plus cos square x by sin square x into cos square x dx. Now this is of the form a plus b by c, a by c plus b by c. Sin square x by sin square x into cos square x. These two gets cancelled. We are left with 1 by cos square x dx. Similarly, cos square x by sin square x into cos square x. Cos square x gets cancelled. 1 by sin square x dx. So this is equals to integral 1 by cos square x dx is secant square x dx plus 1 by sin square x is cosecant square x dx. Integral secant square x dx is tan x minus integral cosecant square x dx is minus cot x plus constant of integration c. The next question is integral 1 plus cos square x by 1 plus cos 2x dx. So with 1 plus cos square x we will write as it is. We know 1 plus cos 2x is 2 cos square x and 1 minus cos 2x is 2 sin square x. So this is 2 cos square x dx. So this is equals to again a plus b by c, a by c plus b by c. This is 1 by 2 cos square x dx plus cos square x by 2 cos square x dx. These two gets cancelled. So 1 by 2 integral 1 by cos square x is secant square x dx plus 1 by 2 integral 1 dx. So integral secant square x dx is tan x plus integral 1 dx is x, so x by 2 plus constant of integration c. Integral 1 minus cos 2x under root dx. So 1 minus cos 2x can be written as 2 sin square x dx. So this is equals to root 2 into root of sin square x dx is sin x dx. So root 2 into integral sin x is minus cos x plus constant of integration c. The next question is integral 1 by cos hx plus sin hx dx. So let us multiply both numerator and denominator with cos hx minus sin hx. Cos hx minus sin hx by cos hx plus sin hx into cos hx minus sin hx dx. So this is equals to cos hx minus sin hx by a plus b into a minus b, a square minus b square. So cos h square x minus sin h square x dx. So in the first year we have learned that cos h square x minus sin h square x is equals to 1 in hyperbolic trigonometric functions. So this is equals to cos hx minus sin hx by 1 dx. Therefore this is integral cos hx dx is sin hx minus integral sin hx dx is cos hx plus constant of integration c. The next question is integral 1 by 1 plus cos x dx. So this is equals to, let us multiply and divide by 1 minus cos x. So 1 minus cos x by 1 plus cos x into 1 minus cos x dx. Multiplying and dividing by 1 minus cos x. So this is 1 minus cos x by a plus b into a minus b, a square minus b square. So 1 square 1. This is cos square x dx. So this is equals to 1 minus cos x by 1 minus cos square x. Sin square x plus cos square x is equals to 1. 1 minus cos square x is sin square x dx. So this is a minus b by c. A by c minus b by c. 1 by sin square x is cosecant square x dx minus cos by sin is cot, 1 by sin is cosecant. So cosecant x into cot x dx. Integral cosecant square x dx is minus cot x minus integral cosecant x into cot x is minus cosecant x. Minus of minus is plus cosecant x plus constant of integration c. With this, we have completed the first exercise. When we are unable to evaluate the given integral using the direct formula, then we have to look for another alternative. So the methods of differentiation enable us to differentiate any combination of various functions, but the integration is not of that kind. So here the given integral can be evaluated using the four methods. They are integration by substitution method, integration by substitution method, integration by parts, integration by partial fractions, by partial fractions, and integration by successive reduction. So let us first discuss the integration by substitution. Now let us discuss the integration by substitution. So the method of substitution or change of variable to evaluate integral f of x dx consists of substituting g of t for x. Substituting g of t for x. So differentiating with respect to x on both sides, then d by dx of x is equals to d by dx of g of t. So d by dx of x is 1 is equals to d by dx of g of t is g dash t into dt by dx. So this is equals to dx is equals to g dash t dt. So this is equals to integral f of x is equals to g of t, x is equals to g of t, dx is equals to g dash t dt. G dash t dt, where g of t is a continuously differentiable function. After evaluating the integral on RHS, again t is to be substituted as t is equals to g inverse x, and substitute this t back in the given equation to obtain the integral in terms of x. So this is the actual procedure, but in practice we do the reversed process, that is integral f of g of t into g dash t dt is equals to integral f of x dx, that is g of t is to be substituted for x. So this is what the substitution method is all about. 2x into e power x square dx. So here x square derivative is 2x. So let x square is equals to t is to be taken. So now dx is the differential operator here. So this is d by dx of so x square is equals to in terms of t. So differentiating with respect to t on both sides. So d by dt of x square is equals to d by dt of t. So let us suppose this x to be t. So d by dt of t square is 2t. So this is 2x into dx by dt is equals to d by dt of t is 1. So 2x dx is equals to dt. So this is equals to, here 2x dx is dt into this is e power x square. X square is t. So this has become the known function. So we can solve the integration for this. It is, we know that integral e power x dx is e power x plus c. Now integral e power t dt is e power t plus c. But ultimately in the answer t is to be replaced back with x square, since the given integrand is in terms of x. So this is e power x square plus constant of integration c. This is how we evaluate the integration using the substitution method. Now let us discuss some standard results of the integration by substitution. Results. So these results will be useful without actually doing the procedure, like something we have to take it as a t and differentiating and ultimately replacing t with the earlier function. So we can avoid all these steps if you remember these results directly. So this is first one, integral f dash x by f of x dx is log modulus of x plus constant of integration c. Integral f dash x by root f of x dx, 2 root of f of x plus constant of integration c. Integral f of x whole power n into f dash x dx is f of x whole power n plus 1 by n plus 1 plus constant of integration c. Integral root f of x into f dash x dx is equals to, so root f of x can be written as f of x whole power 1 by 2. So this is just an application of this. In the place of n, 1 by 2. So 1 by 2 plus 1 by 1 by 2 plus 1. 3 by 2 by 3 by 2. 1 by 3 by 2 is 2 by 3 f of x whole power 3 by 2 plus constant of integration c. And we can even solve this as well. So let f of x is equals to t. Now differentiation will get f dash x dx is equals to dt. Now in the given integral, let us substitute. That is why this method is said to be the substitution method. So here f dash x dx in the numerator becomes dt by f of x is equals to t. So this is equals to 1 by t dt. Integral 1 by t dt is log modulus of t plus constant of integration c. So log modulus of t is nothing but f of x, because as we have discussed earlier that t is to be replaced back by f of x, since the given integral is in terms of x only. So plus c. So log mod f of x plus c. In this way we can prove these results as well. Now let us evaluate some standard integrals. So we know d by dx of tan x is secant square x. Integral secant square x dx is equals to tan x plus c. But what if you are asked to find out integral tan x dx? So how do we do this? Some standard integrals. So integral tan x dx. Integral tan x dx is equals to log mod secant x plus c. Integral cot x dx is equals to log mod sin x plus constant of integration c. Integral secant x dx is equals to log mod secant x plus tan x plus constant of integration c. So integral cosecant x dx is equals to log modulus of cosecant x minus cot x plus constant of integration c. So let us prove them. How do we get these results? And not only that, log secant x plus tan x is log mod tan pi by 4 plus x by 2 plus c. So this has got two formulae, and this is equals to log mod tan x by 2 plus constant of integration c. So let us try to prove them. So integral tan x dx is equals to, proofs. Integral tan x dx is, tan x can be written as cos x by sin x dx. So this is equals to, here if you see, then sin x derivative is cos x. So substitution can be used here, but substitution can be avoided also if you are aware of, if you are familiar with the results. So here what I am doing is, so minus of minus cos x by sin x dx. Without loss of generality, this cos x I have done minus of minus, because sin x derivative is so integral tan x dx is equals to, this is sin x by cos x dx. This is equals to, so this can be done in two ways. If you are not familiar with the results, then actually the straight method, which is a conventional method, we can adopt. Or if you are familiar with the results, then actually without actually doing all these things, you can directly come to the conclusion. So let us try to evaluate in both the ways. One by conventional method of substituting something is equals to t, and second one direct by results. So here cos x derivative is minus sin x. So let cos x is equals to, I'll take it as t. Now differentiation. Whenever we go for the substitution, the immediate thing that should spring to our mind is to differentiate. Differentiate with respect to what? So cos x is equals to t. So here this x is depending on t. Therefore with respect to t is what we have to do. So differentiating with respect to t on both sides. So d by dt of cos x is equals to d by dt of t. So let us consider, assume x to be t. Now d by dt of cos t is minus sin t, in the place of t x, into whatever that we have treated it to be t, we need to differentiate again. So d by dt of x is dx by dt. So d by dt of t is 1. So this is minus sin x dx is equals to dt. So from the next time onwards, so let us evaluate all these things here. Let cos x is equals to t, then d by dx of cos x is minus sin x dx is equals to dt. So we can avoid all these things. Now this is equals to minus sin x dx equals to dt. Therefore what is sin x dx is equals to, this is minus dt. So in the place of sin x dx we will write minus dt by, what is cos x? Cos x is t. So this is of the form integral 1 by t dt minus integral 1 by t dt. So minus it is of the form integral 1 by x dx. We know log mod x. This is log modulus of t plus constant of integration c. But this is not enough. T is to be replaced back by cos x, because the given integrand or given integral is of the form is in terms of x. So minus log, what is t? Cos x plus c. Now this is log mod cos x whole power minus 1 plus c, because this is m log a to the power of m. So this is equals to log cos x inverse. A inverse is 1 by a. So this is 1 by cos x. 1 by cos x is secant x plus constant of integration c. So you may check it out with this. Or if you are familiar with the results, then you can avoid all these things. So integral tan x dx is as usual sin x by cos x dx. The derivative of cos x is minus sin x. So therefore minus of minus I have written here. Now minus is same. Cos x is f of x. Its f dash x. Its derivative is minus sin x. So it is of the form f dash x by f of x. We have already discussed. Integral f dash x by f of x dx is log mod f of x. So this is log mod cos x. Did I tell you? So all this process is not needed. So directly we can arrive to the final answer here. So minus log cos x plus c. So this is again log cos x inverse. So log 1 by cos x log secant x. So in this way, this is the conventional method. That is why it is said to be the substitution method, because this cos x we have substituted by another variable t. That is why this method is said to be the substitution method. So likewise, if you see here, if you see this integral cot x dx, so this integral cot x dx is integral cos x by sin x dx. So directly sin x derivative is cos x. So sin x is f of x. Its derivative is cos x, which is f dash x. It is directly of the form integral f dash x by f of x dx. Log mod f of x. So log mod, what is f of x here? Sin x plus c. So this is the result. So using the result f dash x by f of x dx, actually the steps will be reduced and we can directly evaluate the integrals. Now to evaluate the integral secant x dx, secant x into secant x plus tan x by secant x plus tan x. So without loss of generality, I just multiplied and divided with secant x plus tan x. Now secant x into secant x is secant square x plus secant x tan x by secant x plus tan x dx. So d by dx of secant x is secant x tan x. Tan x derivative is secant square x. Therefore this is f of x and this is our f dash x, because this is to be, if you do not know directly through the results, then no problem. Secant x plus tan x is equals to t. Secant x plus tan x is equals to t. Now secant x derivative is secant x tan x plus tan x derivative is secant square x whole dx is equals to dt. See this here. Secant x tan x plus secant square x dx. Secant x tan x plus secant square x dx. This is dt by, this is t. dt by t is log t. Log t is secant x plus tan x. So this. Now, so how do we get this? Another one. So this is log mod secant x plus tan x. This is integral secant x dx is equals to. So this is log plus c. We can add this plus c at the end. So secant x is 1 by cos x. Tan x is sin x by cos x. So this is log 1 plus sin x by cos x. So this is log 1 plus sin x. 1 can be written as cos square x by 2 plus sin square x by 2. Because sin square x plus cos square x is 1. Cos square x by 2 plus sin square x by 2 is also 1. Sin 2x is 2 sin x cos x. Sin x is 2 sin x by 2 cos x by 2 by cos 2x has got many formulae, among them cos square x minus sin square x. So what is cos x then? Cos x square by 2 minus sin square x by 2. So cos x is cos square x by 2 minus sin square x by 2. Log modulus a square plus b square plus 2ab is a plus b whole square. So this is cos x by 2 plus sin x by 2 whole square by, this is a square minus b square, a plus b into a minus b. So this is cos x by 2 plus sin x by 2 into cos x by 2 minus sin x by 2. So this is equals to, so this and this gets cancelled. So log cos x by 2 plus sin x by 2 by cos x by 2 minus sin x by 2. So this is equals to log, if you divide with the tan cos here, cos by cos is 1, sin by cos is tan. So this is 1 plus tan x by 2 by this is 1 minus tan x by 2, and this can be written as log tan pi by 4 plus x by 2. So tan a plus b, tan a plus tan b by 1 minus tan a tan b, tan pi by 4 which is 1 plus tan b tan x by 2, 1 by 1 minus tan pi by 4. So 1 minus 1 into tan x by 2. So this is what we have got. So in the similar way we can derive this as well. Let us derive some more standard integrals. So we call it as a 6 formulae. Okay, for the sake of convenience I have coined the word 6 formulae. So these are all come under some standard integrals. So first integral 1 by root of a square minus x square dx is equals to sine inverse x by a plus c. Integral 1 by root of a square plus x square dx sine h inverse x by a plus c, or log modulus of x plus square root of a square plus x square plus constant of integration c. 1 by square root of x square minus a square dx cos h inverse x by a plus constant of integration c, or log modulus of x plus square root of x square minus a square plus constant of integration c. 1 by a square plus x square dx is equals to 1 by a tan inverse x by a plus constant of integration c. So 1 by a square minus x square dx is 1 by 2a log a plus x by a minus x plus constant of integration c. 1 by x square minus a square dx is equals to 1 by 2a log mod x minus a by x plus a plus c. So these are the 6 formulae. So these are the 6 formulae. Also these are some standard integrals. Now let us derive. Integral 1 by root of a square minus x square dx is equals to sine inverse x by a plus c. So let x is equals to, we will take a sine theta. So differentiation will get dx is equals to a cos theta d theta. Now substituting this into the given integral, will get 1 by a square minus x square under root dx is equals to 1 by square root of a square minus x is equals to a sin theta, x square is a sin theta whole square, a square sin square theta into dx is a cos theta d theta. This is a cos theta d theta. So this is a cos theta by, take a square in common, then a square into 1 minus sin square theta is cos square theta d theta. So this is a cos theta by, this is a cos theta whole square under root. Square root gets cancelled. We are left with a cos theta by a cos theta. So gets cancelled. Integral 1 d theta is theta. So from this x by a is equals to sin theta. From this theta is equals to sin inverse x by a. Sin inverse x by a plus c. So this is what we need to prove. Similarly, a square plus x square dx. Take x is equals to a sin h theta. So to prove this, I'll just alterate here. X is equals to sin h theta. X by a is equals to sin h theta. Now dx is equals to a cos h theta d theta. So this is a cos h theta d theta. So this is a sin h square theta. So this is a square, if you take common, 1 minus sin h square theta is cos h square theta. So this is a cos h theta by a cos h theta. So gets cancelled, we are left with theta. So these two gets cancelled, we are left with theta d theta. So x by a is equals to sin h theta. So theta is equals to sin h inverse. This 2 gets cancelled, 1 d theta. 1 d theta is theta plus constant of integration c. What is theta here? Sin h inverse x by a plus c. So similarly we can prove this as well. So as far as the fourth one is concerned, x is equals to a tan theta, dx is equals to a tan theta derivative is secant square theta, d by d theta of tan theta is secant square theta. So substitute this in this. 1 by a square plus x square dx is equals to 1 by a square plus x is equals to a tan theta, x square is a square tan square theta, into dx is a secant square theta, a secant square theta d theta. So this is a secant square theta by, take a square in common, then we'll get 1 plus tan square theta d theta. So this and this gets cancelled. So 1 by a, since a is the constant, I am separating from the process of integration by, this is secant square theta by secant square theta minus tan square theta is equals to 1. So 1 plus tan square theta is secant square theta. These two gets cancelled. So 1 by a, integral 1 d theta is theta. So this is 1 by a. From this, theta is equals to, so x by a is equals to tan theta, theta is equals to tan inverse x by a. So tan inverse x by a plus c. If you do not understand, I will show here. X by a is equals to tan theta. So theta is equals to tan, if you transpose according to inverse trigonometry function. So this theta is equals to tan inverse x by. So let us evaluate integral 1 by a square minus x square dx to be 1 by 2a log mod a plus x by a minus x plus c. So let us consider 1 by a square minus x square. So this is 1 by a plus x into a minus x we can write. So this is a proper fraction with the degree of f of x is 0 and degree of g of x is x into x square 2. So degree of f of x is less than degree of g of x. Therefore partial fraction method is used here. So if you want to know what partial fractions is all about, so I have made a video on the partial fractions chapter. So you are requested to watch them. But anyway, once again we will be discussing the method of integration using the partial fractions we will be discussing. So for the time being, the denominator contains two non-repeated linear factors. For every non-repeated linear factor corresponds to a x plus b, there exists a partial fraction of the form a by ax plus b. So therefore here a by a plus x plus b by a minus x. So if you find the LCM for this, a plus x into a minus x, this is a into a minus x plus b into a plus x. So these two gets cancelled on both the sides in the denominator. So 1 is equals to a into a minus x plus b into a plus x. So here a minus x being a linear factor equated to 0, a equals to x or x equals to a. X equals to a is the root of solution and root has to satisfy the equation. So put x is equals to a. Implies 1 is equals to a minus a 0. So b into a plus in the place of x a plus a 2a. b is equals to 1 by 2a. Put x is equals to a plus x is a factor equated to 0, x equals to minus a. So now 1 is equals to b a into a minus of minus a plus a 2a. This minus a if you substitute here it will be 0. So again a is equals to 1 by 2a we get. Therefore 1 by a square minus x square is equals to, the value of a is 1 by 2a by a plus x. 1 by 2a into a plus x. Because a by b by c is a by bc. Plus the value of b is 1 by 2a by a minus x. This is this. Now integral dx. So integral of dx. So in both of them 1 by 2a is common, separated from the process of integration. 1 by a plus x dx plus 1 by a minus x dx. So this is equals to 1 by 2a. Now this is of the form integral 1 by x dx. Let us suppose this to be x. Integral 1 by x dx is log x. So log mod x plus a by whichever that is taken it to be x temporarily, we need to differentiate it. In differentiation we used to do d by dx of a plus x, but here by d by dx of a minus x. D by dx of a is 0, d by dx of x is 1. So by 1 anyway this is what we are going to get, because by differentiation and integration of the opposite process. So earlier in the differentiation this we used to take it as x. So later after treating it to be x, later we need to differentiate into d by dx of this, but here by d by dx of this. Likewise this is 1 by a minus x. So let us suppose this to be x. Integral 1 by x dx is log mod x again. So log mod x minus a by d by dx of a minus x. A is 0, minus x is minus 1. So this is minus. So 1 by 2a log a minus log b is log a plus b. So this is a plus x. This is a minus x, right? This is a plus x by a minus x plus constant of integration c. Because I did not do anything, this I have treated to be x. Integral 1 by x dx is log mod x, same, by d by dx of minus x. A minus x is minus 1, that minus here I have written. So this is how we will evaluate. In the similar way, integral 1 by x square minus a square dx equals to 1 by 2a log mod x minus a by x plus a plus c we can show.